Okay, so we talked yesterday about all the different operations with numbers. Today I want to look at what happens when we run into a problem like this. When we look at that, that's not going to work out real well. Let me change one little thing here, just to make that a little more user-friendly. And if we look at that, there are a lot of things that would make sense to do that problem. I mean, we read working left to right. It would maybe make sense to do the problem left to right. Do the 12 minus 5 first, and then times 2, and so on. Problem is that wouldn't be correct. That won't give you the right answer. In order to make sure in math that everybody looks at a problem like that and does it the same way, we've created something called the order of operations. Now, the order of operations is often described as a set of steps. And that's not quite correct. What the order of operations really is levels of priority. So what that means is the higher up on that list something is, the higher priority it has to have. Things at the top of the list have to happen before things at the bottom of the list. Our highest level of priority, things that have to happen first, is something called enclosing symbols. Now, many of you have probably heard this as just parentheses. Parentheses are one type of enclosing symbol. And we have different variations of parentheses, like the brackets and the square parentheses and so on. Those are all considered enclosing symbols, along with a few other things that we are going to see that are also enclosing symbols. An enclosing symbol is anything that separates one part of the problem from the rest of the problem. Our second level of priority is exponents. Exponents include two things: powers and roots. We talked a little bit yesterday about operations coming in pairs. Addition and subtraction work together. Multiplication and division work together. Powers and roots work together. They're inverses of each other. So they're really the same thing. One's going forward, one's going in reverse. The next thing is multiplication and division. So what that means is we can only do multiplication and division if there are no enclosing symbols to deal with and no exponents or powers or roots to deal with. And then the final thing on our list of priority here is addition and subtraction. So we only do addition and subtraction if there's nothing else left to do. Now, this is not a complete list. There are several other things in math, several other operations that are not listed here. We recognize addition and subtraction as being a pair of operations, and probably multiplication and division. Exponents, powers, and roots are another pair of operations like that, as we said. But there are other pairs. There are trig functions and trig inverses that are not here, but are part of the order of operations. There's logarithms and exponentials that are a pair of inverse operations that are not on here. We're not going to deal with logarithms and exponentials for you guys for the most part, unless you're in broadband. You'll see a little bit of that. So we're not going to deal with them in the order of operations. Both groups will see the trig functions and their inverses. Yes, sir. Yep. Well, distributing is something that comes when you're dealing with algebraic numbers. You would multiply for, if there's stuff in the parentheses to do and it's all numbers, you can combine them. Distributing really only comes in if there's algebraic numbers in there, so there's stuff that you can't combine inside the parentheses, then distributing comes in. A variable, yeah. Yeah, something that makes it so you can't combine what's in there. So back to our original problem that we proposed here. Are there any enclosing symbols up here? No. Any powers or roots? No. So we're left with multiplication and division. So we're going to have to do the 5 times 2 first, which is 10. So what happens is I remove the 5 times 2 and I replace it with 10. The rest of the problem remains unchanged. Now all that's left is addition and subtraction, but there's more than one of them to do. So when I have more than one item that's at the same level of priority, that's when we do go left to right, just like reading a book. So we do 12 minus 10 next, which is 2. So again, I remove the 12 minus 10, replace it with 2, and the rest of the problem stays the same. 2 plus 6 is 8. So the result of that problem is 8. Now, by the way, if you have a calculator, scientific calculator, and you're good with it, if you type that problem incorrectly, it will do the order of operations correctly. So you can see there it does pop out 8 for you. Well, let's look at something that's a little bit more complex. Just slightly more complex. As I look at this one, what has to happen first? Enclosing symbols. And now we said when there's more than one thing on the same level, we work left to right. So there's more than one set of parentheses here, so we're going to work left to right. And this is the first one we find. We need to find its other end. Is this one it? Nope, that's facing the wrong way. How about this one? Nope, that goes back to this last one. So we go all the way down here to find the other end of that set of parentheses. So we're going to start out working inside that set of parentheses, inside the green box, if you will. However, inside there, our order of operations still applies. So are there any other enclosing symbols inside that? Yes, there's another set of parentheses. So we move inside there. So now let's look inside the purple box. Inside there, are there any other enclosing symbols? No. Are there any exponents? No. Multiplication or division? Yes, there is. 2 times 6, which is going to give us 12. So take out the 2 times 6 and replace it with 12. Nothing else changes. So we erase the rest of the problem and replace that 2 times 6 with 12. So now we're still inside that purple box here, brown box now I guess it is. All that's left is subtraction. So 13 minus 12 is 1. So I replace the 13 minus 12 with 1. Now I'm going to start cheating here a little bit, just because it takes a lot of time to rewrite the whole problem every time. And also for you guys, I have found that most of the mistakes people make come from rewriting the rest of the problem, not from doing the steps. So when you're doing it, I have no problem with you just erasing and replacing like what I'm doing here. Otherwise, be very careful writing out the rest of that problem. So now we had the 13 minus 12 gives us 1 here in the parentheses. When we reduce a parentheses to a single number, we don't need that parentheses anymore. So I can take out the parentheses. So I can take that parentheses out. It's all done. Just leaving with the 1 there. It was the result inside that parentheses. So now we're back out to this bigger set of parentheses. And we have to start over our levels of priority. Are there any other enclosing symbols? No. Exponents. Yes, there are. There's the 3 squared, right? 3 to the power of 2 is 9. So I take that out, replace it with 9. I've got the minus there. Plus 18 divided by 6, close parentheses, plus 3, 1, 9. So again, all I did is remove the 3 squared, replaced it with 9. Everything else stayed the same. So now inside, we're still working inside that set of parentheses. Any other exponents? No. Multiplication or division? Yes, there is. We have that 18 divided by 6, which is 3. So I take that out and replace it, rewriting the rest of the problem. Any other multiplication and division inside that parentheses? No. All that's left then is addition and subtraction. So we are going to work left to right. We've got the 9 plus 1 is 10. Next we have 10 minus 9 is 1. Next we have 1 plus 3 is 4. Now we've reduced what's in that parentheses down to a single number again. So I don't need the parentheses anymore. I wrote it in here just for a second to make a point. If I take that parentheses out though, we have this 2 here, and there's no symbol between the 2 and the parentheses. What operation is implied there? It's implied that that's multiplication. Anytime there's a number on the outside of a parentheses without any operation or symbol there, it's implied to be multiplication. So when I take out the parentheses, I do have to put that in, that is 2 times 4. Well, now all the parentheses are gone. Are there any other enclosing symbols? No. Exponents? No. Multiplication or division? Yeah, 2 times 4 is 8. And now all we have is addition going left to right. 7 plus 8. 15 plus 3 is 18. Any questions? Yes. Well, it's minus 3 squared. So you've got to be careful with that. There's a difference between 7 minus 3 squared than a negative 3 squared. On your calculators, most of your calculators, and we'll talk more about negatives in a couple of classes. But if I just do negative 3 and I square it, it's going to try to tell me negative 9, and that's not correct. You have to put it in parentheses, negative 3 and then squared is a positive 9. Some people will have you change it. In this case, I probably wouldn't recommend it. But some math teachers would have you change that then to plus a negative 9 like that. But once we talk about negatives, we'll get into that as well. Were there any other questions? Okay. I'm going to have you guys try one in your notes quick, and we'll go over it here in just a minute or so. Give that one a shot in your notes. We'll go over that in just a minute. Okay, so where do we start? Parentheses. Very good. So inside the parentheses, what do we have to do first? Multiply the 2 times 4, which is 8. So replace that in there, and nothing else changes. And this is where I'm going to start to cheat. What's next? 11 minus 3, which is, or 11 minus 8, which is 3. There we go. Little hamsters left the wheel for the day already. Now we're down to a single number in the parentheses, so we can get rid of them. What do we have to do? Put in the multiplication there. Now what? We're going to do multiplication, division, left to right. 3 times 3, which is 9. What's next? 24 divided by 8, which is 3. Then we can do the 3 times 2, which is 6. Remember, multiplication and division happen at the same time, so we just go left to right with them. Then we have addition and subtraction. 7 plus 9, 16 minus 6 is 10. How many of you had 10 for that one? Anybody have questions as to how we got there? It's just a matter of being very careful and following the steps and looking through it. This takes some practice. A little bit. Oh, sorry about that. If you have to, you can go back to the recording and check them out. Did you go ahead and write them all out? Good. A variation that we'll see might look like this. Seven times 9 plus 3 times 6 over. Here, you got something off? That'll do it. Something like this. That ain't gonna work. Let's just do this. So when we look at a problem like this, the first thing we've got to figure out is what this line across here means. Okay, division is what most people would say. It's called a fraction bar, and it does mean division. We are going to divide, but it's also an enclosing symbol. It's telling us that we have to do everything on top first, then everything on bottom, and then we can divide. It's separating one part of the problem from another. So let's start out by doing everything on top. What do we have to do first there? Multiply left to right. So 7 times 9 is 63. And then 3 times 6 is 18. 63 plus 18 is 81. So the top of this is equal to 81. On bottom, what do we have to do first? Parentheses, 3 plus 2 is 5. Now what? We'll get rid of the parentheses. Well, we can get rid of the parentheses and make that 5 times 5. And you are right. What we need to do next is the 4 squared, which is 16. And then we're going to multiply. 5 times 5 is 25 minus 16 is 9. So the bottom is 9. Now that we've completed everything on top and everything on bottom, now we can divide. 81 divided by 9 is 9. So that's another form of enclosing symbol that we run into. Another one might look like this. Something like that. Looking at this, what has to happen first? Exponents. In fact, we have this square root symbol here, which is not only is it an exponent, but it's also an enclosing symbol. It separates what's inside of it from what's outside of it. So we have to start inside of it. Now inside of it, there's no other enclosing symbols, but there is another exponent, the 3 squared, which is 3 times 3 is 9. So we replace that with 9. Now we still have to be working inside the square root. What comes next? 7 times 9 is 63. What's next? Addition. 1 plus 63, 64. Now, just like with parentheses, once we've reduced what's in that square root to a single number, we can take out the square root. The difference is in the parentheses, we just took out the parentheses and we put in any necessary multiplication. When we take out the square root symbol, we actually have to perform the operation. What is the square root of 64? 8. So we take out that square root of 64 and replace it with 8. Now, just like parentheses, that 4 was in front of the square root with no operation. That's implied to be multiplication. Now what? Multiply. Left to right, 8 times 7. 56. Very good. And then 4 times 8 is 32. And finally, yes, 56 minus 32 is 24. Any questions? A lot of work for 24. Yes, you had to square root the 64 when you had it down to a single number inside the root there. Okay. It's a little bit early, but if you go by the clock on the computer, it's 2:04, almost 2:05. So it's only about 15 minutes for the homework. Usually I try to give you 10 to 15 minutes to start on your homework. So I'm going to have you, this is going to be in your big book. I believe it's page 24. It's labeled exercise 1-11. 1 through 33, the odds. Just like in your little book, the answers to the odd number problem should be in the back of the big book. Please feel free to check your work as you're going through it. I forgot to ask the class, anybody have any questions on the homework from yesterday? It was addition, subtraction, multiplication, division. Okay. Yeah, it was units 1, 2, 3, and 4 out of the little book. As always, if you do the first couple and they seem really simple, skip ahead a few. Make sure you do some of the longer ones here, though, because there will be some on a quiz and the test that are longer like those.